Algebra. Before we start, what is algebra? Algebra is the branch of mathematics that deals with general statements of relations utilizing letters and other symbols to represent specific sets of numbers, values, vectors, etc. in the description of such relations. So the definition came from www.dictionary.com. To put it in a simplest term, for example, I would be giving you a gift. First thing that will come to your mind is, I want to open the gift, because you do not know what's inside the gift. Okay? For example, I am your close relative, a very close relative, like your brother or your uncle or your father. So if I'm your brother, you would think, what kind of gift would I give you? If I'm your uncle, what kind of gift would I give you? So you would think it's just a stuffed animal or stuffed bear, or a game console that can fit a gift box, or a bicycle if it would fit in a small gift box, or simply came from McDonald's, a Happy Meal. So based on our concept, what is now the meaning of algebra? So for me, algebra is actually representing an unknown with a variable, which is actually any letters in the alphabet. Okay? So from A to Z. Sometimes it is followed by a number. So if you love letter A, you can use letter A to the whole equation, but we just followed it by a number. For example, A1 until to Z1, A2 until to Z2, A3 until to Z3, and so on and so on. It's just like my favorite TV show when I was a child. There is this Bananas and Pajamas. They call themselves B1 and B2. But B1 is different from B2 because B1 is the eldest and B2 is the youngest. But they use the same variable, letter B. They just denote it with a number to show the difference between B1 and B2. So example number 1. 4 boys are throwing javelins. Tom threw a javelin X meters. So there is already what we call the letter X. Okay? As you can see, there is this letter X. X can be any numbers from integers. Okay, let's remove the coloring. John threw a javelin half as far as Tom. Now we use the word half. So what do you mean by half? Okay, next. Jim threw a javelin 12 meters further than John. So you can see the 12 meters is further. So what does we mean by further? And next, Jack's throw was 3 meters less than Tom. So we use another term, less. What do you mean by less? Okay, so the 4 boys, we have Tom, John, Jim, Jack. So the first problem is we need to write expressions using X for how far John, Jim, and Jack threw their javelin. Okay, so we have here a simple table. We have the name of Tom, John, Jim, and Jack, and the symbol. We will be using these to the next examples. So the symbol, we use T, that represents Tom. We use J1, which means John, J2, which means Jim, and J3, which means Jack. So can you complete the table? For our first example, we have X for Tom. So what do you think is the expression of John, Jim, and Jack? Okay, now we answer. Tom threw a javelin X meters. So as you can see, this X meter is means a distance. It means a number of distance from where Tom is first standing going to the javelin, the throw of javelin. So how far is X meters? So we do not yet know. So next we have John threw a javelin half as far as Tom. So take note, Tom is equal to X meters, or Tom is equal to just simple X. So what does we mean by half? Okay? What does we mean by half? What do we mean by half? Have you an idea? Okay. So John threw a javelin half as far as Tom. So we denote half as 1/2 X meters. So we can write it as either X over 2. But we would be using 1/2 times X meters to make it simply, because 1/2, we know that 1/2 is just half. So next, Jim threw a javelin 12 meters further than John. So recall, we have Tom, which is equal to X meters, and John, which is equals to 1/2 X meters. So let's see, have you an idea what does further means? Okay. So Jim threw the javelin. So the distance is measured by equal to 1/2 X plus 12 meters. So what we mean by further is far away. Okay? It means a little bit far. The root word far. So we add 12 meters to the answer we have from John. So it would be 1/2 times X plus 12 in terms of meters. And next we have Jack's throw was 3 meters less than Tom. So we recall again our values we get from the previous slides. We have Tom, which is equal to X meters, John, which is equal to 1/2 of X meters, with G and Jim, which is equal to 1/2 of X plus 12 meters. So what do we mean by less? So it's less than Tom. Okay, we'll look at it. So we have X minus 3 meters. X came from Tom, which is equal to X, and 3 meters is came from the problem, which means 3 meters less than Tom. So Jack's row is less than Tom with a variable of 3 meters. So the summary of our expressions, we have So we have X meters for Tom, we have 1/2 X meters for John, we have 1/2 X plus 12 meters for Jim, and we have X minus 3 meters for Jack. Okay, what if x is now equal to 50 meters? So we need to calculate how far each of the boys threw the javelin. Okay, we'll start with Tom. So Tom threw a javelin 50 meters. So take note, we already substitute 50 to x. Okay, so we have a table again. We use the same table with the Tom, John, Jim, which has a symbol of P, J1 and J2 and J3. So the expression we have for Tom is x. And our problem now is given if x now is equal to 50 meters. So our answer would be 50 meters because x is actually equal to 50 meters. So John threw a javelin half as far as Tom. So what do you think is the answer? Is the distance of the javelin of John? Okay, from the problem we have 1/2 times 50. So J1 is equal to 25 meters. So the javelin of John is equal to 25 meters. So Jim threw a javelin 12 meters further than John. Okay, we have the table. We already have the expression of x, 1/2 of x, and now we'll be getting the expression and the answer for Jim. So J2, which is the symbol we use for Jim, is 1/2 x plus 12. So J2 now is equal to 25 plus 12, which is equal to 37 meters. So the distance of the javelin which Jim threw is 12 meters further than John, or 37 meters. So Jack's throw was 3 meters less than Tom. So J3 now is equal to x minus 3. Okay, so we know that x came from Tom, which is equal to 50. So we have 50 minus 3, which is now equal to 47 meters. Okay. So as our summary for the example, we have if x is equal to 50 meters, so we have Tom for 50 meters, Jim for 25 meters, John for 25 meters, Jim for 37 meters, and Jack for 47 meters. So exercise number 1. So exercise, I need you to perform the activity, the exercise, and a piece of paper, and pause the video or pause the videos and play the video again to check if your answers are correct. So exercise number 1, we have 3x, which is equal to 2x plus 3. Number 2, we have 2x minus 4, which is equal to x plus 3. And number 3, 2 plus 3x is equal to x plus 4. So you need to pause the video or do not proceed to the next slide, and proceed only if you have already answered the question. So we answer the first problem, which is 3x is equal to 2x plus 3. So first things first, we need to move we need to move first the variable of x from the right side. We'll move it going to the left side. So it will become 3x minus 2 of x. So take note, we have already here a negative value. Because from positive, this 2x here is positive. When you move it going to the left side, we will change the sign of 2x going to negative x. So what you're gonna do is always move the smallest value of an integer with x going to the higher value of an integer with x. So we are going to group the x's and we're going to group the integer or the numbers only without the variable. So our answer now, since 3x minus 2x, it would become just equal to x. So take note, x is not only a letter, but it has a number 1 beside it. So why do we not write 1 with it? Because any number multiplied to 1 is just equal to the number itself. So to check if our answer is correct, that x is equal to 3, we need to substitute 3. We need to substitute 3 from 3x, and we need to substitute 3 from 2x using the original equation, which is 3x is equal to 2x plus 3. So to check, 3 times 3, so when we put here a parenthesis, we are intended to multiply the numbers together, okay? So 3 times 3 is equal to 2 times 3 plus 3. So we are following first the BODMAS or the PEMDAS rule. Multiplication or parenthesis first, multiplication, division, addition, and subtraction. So 3 times 3 is equal to 9 is equal to 6 plus 3. We have both sides equal to 9. Okay? So if the left side is 9, the right side should be also equal to 9. So what do we learn from this example, from this exercise? What rules do we need to put ourselves? Okay, there are certain rules we need to follow. First is we group the variables and integers. Okay? Group variables and integers. When we say variables, we group all the x's and all the numbers without letters with it. Okay, number 2, we place the group on one side. So as you can see, we place both. Where is this? Remove this line. Yeah, so we place both the x on one side and the 3 without the x on the other side. Then we perform basic mathematical function. So what is a basic mathematical function? It is addition, subtraction, multiplication, and division. Okay, we answered number 2 problem, which is 2x minus 4 is equal to x plus 3. As you can see, we have already both sides with just a number without a variable, which is negative 4. We consider this negative 4 and positive 3. Okay? So always take note, the operator with the number is always equal to a negative or a positive number. So 2x minus x equals 4 plus 3. So what does it happen? We move negative 4 because negative 4 is a very low number or a very low integer. So negative 4, we move negative 4 going to the right side. If you notice, the negative sign is already changed to the positive sign. In the x here, and the x on the right side, we move it going to the left side. So the positive value of x will now turn into the negative value of x. So we group for the x's on the left side and a number without letters on the other side. So now 2x minus x would be equal to just simple x, because x without a number is just equal to 1x. So 2x minus 1x is just equal to x. And 4 plus 3 is equal to 7. So to check, we have 2 times 7 minus 4 is equal to 7 plus 3. So 2 times 7 is equal to 14. 14 minus 4 is equal to 10, which is 7 plus 3 is 10. And 14 minus 4 is equal to 10. So both sides now has equal values, same 10. So what are the rules again? So group variables and integers, place the group on one side, and perform basic mathematical function. The last problem, which is 2 plus 3x is equal to x plus 4. So what you will do is group all the x, all the variables, and we'll group all the numbers only. So we get 3x minus x, which is equal to 2x, and 4 minus 2 is equal to 2. So how do we get just simple the value of x? We need is the value of x. So if this happens, we need to divide both sides by 2. Because this 2 came from here. We need to eliminate the 2 of x. Okay? To eliminate 2, so that we remove the number 2 with the x, we need to divide both sides by 2. So x now is equal to 1. To check, okay. So always remember the rules. Okay, thank you. So exercise 2A. 3 families visit a theme park. So C is the cost of admission. So the letter C is the cost for admission for a child. And A is the cost of admission to the theme park for an adult. So what we're going to do is write an expression for the entry cost for each family. So we have the Andrews family, the Barnes family, and the Singh family. So we can see that there's an adult and a child. So all the families have adults and child with it. So we need to write C, we need for the cost of admission for a child, and A for the cost of admission for an adult. So you need to pause and try to answer it on a piece of paper and continue to check if your answers are correct. So A, let's start with the Andrews family. How many adults do we see? So we have the father, the mother, the eldest son, the youngest girl, the youngest brother, and the toddler. So we have AA, A, C, C, C. So what do we need to do there? We need to group all the variables with the same letters together. So it's A plus A plus A plus C plus C plus C. So we have 3A plus 3C. For the Barnes family, we have a single mother and a child, a boy child, and a girl child. So it's just A, C, and C. So if we write it into an equation, because we need to get the admission cost, it's A plus C plus C. So we have just a single A and 2 of C. So our answer would be A plus 2 C. For the same family, we have 3 adults and 2 children. So we'll write it as A, C, C. So A plus A plus A plus C, which is equal to 3A plus 2C. So do we have the same answer? Okay, exercise 2B. If the cost for a child is 12 pounds and the cost for an adult is 21 pounds, calculate the cost for each family and then for your own family. So you need to create your own family picture and compute for the cost of the theme park, the admission for a theme park. So the same family, we have the Andrews, the Barnes, and the Singh. So you need to pause and continue to know the answer. So for Andrews family, if we have already 3A plus 3C, we just substitute A and C with the values given by the problem. So we know that A is equal to 21 and we know that C is 12. So you need to just substitute A with 21 and C with 12. So what do we perform by 3 with a parenthesis 21 and 3 with a parenthesis of 12? So remember the rules. We need first to multiply, divide, add, or subtract. So multiplication first, then division, then addition, then subtraction. So in this problem, we have the parentheses. In this parenthesis, we use the operation multiply. So you multiply 3 times 21 first, and you multiply 3 times 12 first before adding them up. So it's equal to 3 times 21 plus 3 times 12. So 63 plus 36 is equal to 99 pounds. For the Barnes family, we have A plus 2C. So 21 plus 2 times 12. So we know that C is 12 and we know that A is 21. So without a number with A, the variable A, we don't need to multiply it to any numbers. So we just multiply it to 1, which is just equal to 21. Okay, so 21 times 1 is 21. So 2 times 12 is 24. So 21 plus 24 is equal to 45 pounds. For the same family, we have 3A plus 2C. So we substitute A with 21 and C with 12. So we have the answer of 87 pounds. Okay? So do you have the same answer? And thank you for doing the activity.